We fly multi-engine airplanes for two main reasons. Better performance in the form of greater load-carrying capability, climb rate, range, and speed, and greater safety, not only in the form of a backup engine, but also in terms of redundant systems.
When it's being flown by a pilot who's proficient, who's well-trained, who's not breaking the rules, the twin is a safer airplane.
It's a great deal if you've got the cash and can handle some added complexity. But the safety side of the bargain comes with strings attached. And if you want that extra safety to be more than just a comforting illusion, there are some rules you need to follow. Rule number 1, respect the aircraft's limitations. As a new multi-engine pilot, the first time you go tearing down the runway, it can be a real rush. The airplane leaps off the ground, and you feel like it could do almost anything. Of course, we know that's not literally true, but the mindset does have a way of bleeding over into real-life thinking.
You have to realize that this is still a general aviation airplane. This is not an airliner.
There are two things to keep in mind here. First, having a better climb rate, anti-ice systems, radar, and so on doesn't mean tackling any weather or carrying any load. Second, if you imagine that a twin loses 50% of its vertical performance when it loses 50% of its power, well, you're wrong. It's more like 80 or 90%.
Instead of a thrust producer, you've got a drag maker, you've got dead weight of 500 pounds of motor.
And things are even worse without the prop feathered.
It's really double-edged sword because you've got the drag of the propeller, plus you're not getting the air flowing over the wing behind that propeller.
It's a critical point that's too often overlooked. Depending on conditions, there's no guarantee that you'll be able to climb or even maintain altitude with a failed engine in a typical piston twin. And that's assuming you do everything right, not only feathering the propeller and using the correct control inputs, but raising gear and flaps and keeping them up until landing is assured.
Having that extra engine gives you extra time to find a place to land.
There's also the issue of initial training, which in many cases is not a good indicator of what to expect in real life.
Typically, they're doing it with one flight instructor, half tanks of fuel, maybe it's in the spring or fall. That aircraft is going to react totally differently in the summer if you're at a high-density altitude airport, if you've got a full load of people on board.
And that brings us to rule number 2. Plan like a pro. It may not sound fair, but even though you shouldn't treat your piston twin like a miniature airliner, you should aspire to flight plan like a professional pilot. Simply because the range of possibilities is greater, and in many cases, the margin for error is slimmer.
Before takeoff, you know, okay, all I'm going to be able to do is find a field and land, that this isn't going to climb and even necessarily bring me back in the pattern here at this airport.
That also means giving special consideration to performance at airports with nearby terrain.
When it comes to loss of an engine, most likely will not be able to maintain a minimum climb gradient, and therefore your clearance above terrain will be limited or very threatened.
In recent years, the use of flight risk assessment tools and safety management systems has become much more common in corporate and charter flying. The goal is to have a more objective backstop for decisions that used to be entirely on the pilot's shoulders. And there's no reason you can't use the same thing.
A risk analysis tool is really important for those people so that it can help with the decision making and to make it much more objective as we go or we don't go on this particular day.
A variety of commercial products are available, and in fact, the Air Safety Institute has developed its own free online flight risk assessment tool. Taking a systematic, professional approach to flight planning is not only a good practice in itself, but it helps develop the kind of mindset that's necessary to operate safely in a multi-engine aircraft. During a late-night departure, the pilot of a Cessna 421 neglected to raise the airplane's gear and flaps. A few minutes later, the slow-climbing aircraft impacted high terrain near the airport. There was no sign of mechanical failure. accident investigators concluded that fatigue likely played a role in the pilot's failure to follow standard procedures or recognize his mistake. Rule number 3. Cut yourself some slack. We've all heard it before. The performance numbers in your POH or flight manual were achieved by professional test pilots flying brand new airplanes. Your results may vary. That's true, and it goes double for twins. More than ever, it's important to think of those numbers as best-case scenarios rather than expected outcomes.
Do you really want to find out, can I simulate that to the edge? Or is it, I think it's obviously just good common sense to give yourself a little extra, whatever percent you determine that might be.
So how do you go about building in that extra margin? There are no set rules. Maybe it's adding 50% to the accelerate stop distance. Or maybe it's something as simple as not topping off the tanks before you put the airplane in the hangar. Of course, as with any airplane, having and following personal minimums is an excellent practice.
You sort of want to dip your toes in the water, just check the temperature. So you'll kind of expand your personal minimums every time based on your comfort level. Say you've got 100 hours in this specific airplane and you know the navigator, you know the autopilot, you know how everything is working, you work it very proficiently, then obviously you can expand your personal minimums.
Here's a very simple rule of thumb. In an airplane with a failed engine, it's always better to be a few knots fast than a few knots slow. For that reason, one good practice is to add a few knots to VYSE, best single engine rate of climb speed, or blue line on most airspeed indicators. Many accidents in twins are caused by a loss of directional control, the so-called VMC roll, which happens when you drop below the speed at which control inputs can compensate for the differential thrust and other forces with one engine failed and full throttle on the other.
Typically, multi-engine aircraft have anywhere from rotation to about 400 feet is the critical point. And different multi-engine aircraft will go through that danger zone slower or faster than others.
As seen in this tragic real-life example, during an engine failure situation close to the ground, the temptation to pull back to eke out just a bit more climb can be strong. But it's a situation in which the cure can be much worse than the disease. During simulated engine-out training, the right engine of a Beech Duchess was inadvertently shut down. Restart attempts failed. The CFI and student decided to return to the airport and land on one engine. With the aircraft established on a straight-in final, the CFI decided to go around and land in the opposite direction. His reasoning? With taxiway exits on only one side of the runway, it would be easier to turn off after landing. The CFI took over for the go-around, but failed to raise the gear. On downwind, the aircraft was still descending and slowing. At 100 AGL and 65 knots, the aircraft rolled to the right and nosed over, impacting terrain. The 3 occupants survived with serious injuries. Rule number 4. Proficiency is key. Last, and perhaps most important, is the thing that makes the rest of this possible: staying proficient in the airplane. That not only means everyday operations, but emergency procedures as well.
Complacency was the big thing, because when you're out doing it all the time, it's a lot easier to figure, well, I'm not going to go pull the engine on myself when I take off.
Especially in larger or less common twins, it's a good idea to seek out aircraft-specific training from an instructor or organization well-versed in the type.
If you don't fly a lot, I think you need to do at minimum annual recurrent training in the actual airplane. Type-specific organizations, especially like the American Bonanza Society, has its Bonanza Baron Pilot Proficiency Program. So you'll have a BPPP instructor fly with you in your airplane to bring you up to speed.
For many owners, the cost of proficiency becomes an issue. The good news is that you don't necessarily have to spend a ton of money to stay sharp. A lot of proficiency is just being mentally engaged in the subject and newer simulators are great for practicing procedures and different weather and performance situations.
So for someone who couldn't afford to fly it on a regular basis, I would say that investing in that time of having, whether it's the cockpit poster for chair flying or just some sort of poster, or using like a sort of home simulator to practice on that and to be able to stay proficient, that goes a long way, because being mentally in that game, mentally going through your procedures, will definitely keep you current. I have no doubt about that.
Another thing to remember is that abnormal and emergency situations aren't limited to the things commonly practiced in training. We rarely talk about partial power loss, for example, but in reality, it's much more common than outright engine failure.
You might lose oil pressure, the oil temperature goes up. Sometimes you'll have surging on the engine. If the power just drops back to 40% and stays there, okay, you still have a little bit of a decision to make, because great, if I'm climbing, I'm gonna maybe want to keep whatever I've got, so that I can climb. If you're coming in to land at the airport and you think this thing might fail, and do I want to come in on partial power or shut it down, be completely stabilized?
Finally, proficiency will help you both to speed up and slow down in the cockpit. That may sound strange, but by speed up, we mean that it helps you anticipate and more quickly deal with abnormal situations. And by slow down, we mean that you'll be calmer and less likely to rush or make panicky mistakes.
It actually helps to calm you, like, okay, do what I've been taught to do and go through the procedures.
Of course, there's a lot more to flying safely in a piston twin than we can cover here. But if you follow these 4 general rules, being realistic about the airplane's limitations, putting greater emphasis on flight planning, building extra safety margins into your operations, and making the effort to maintain a higher level of proficiency, you'll be in a much better position to really take advantage of the greater safety offered by that extra engine.